Hi, welcome to Such and Study Tech. Today topic is red black tree. So what is meant by red black tree and how can create red black tree? Red black tree are another type of balanced binary search tree. You know already balanced binary search tree means you know left values less than root less than right values. Okay, so here what is the major difference between red black tree and AVL tree? AVL and red black tree are balanced binary search tree. Okay, so first you can discuss one example problem, then you can understand what is the difference between red black tree and AVL tree. Okay, so here with two color nodes, that is each and every node having either it is red color or black color. It is self-balancing binary search tree that makes use of these colors to maintain the balance factor. In AVL tree, we are discussing balance factor. The balance factor must be equal to 0, 1, minus 1. But in this case, the balance factor means it is a color balanced. Okay. So first you can discuss the insertion algorithm in this video. Later video can discuss how can delete node from that red black tree. Different conditions. What is the red black tree property? So the first property is the root node is always black in color. No two adjacent nodes must be in red color. That is second property. Every path in the tree must have the same amount of black color nodes. This is even though AVL tree are more balanced than RB tree. What is meant by more balanced? Okay, with the balancing algorithm in AVL tree being stricter than that of RB tree, faster insertion deletion operations made more efficient through RB tree. So what is the meaning of this? Now we can discuss. I am considering this red black tree is also called as RB tree. Here it is also called as RB tree. So what are the three properties? Now we can see the first property is root node must be black color and no two adjacent nodes are red color, and each and every path equal number of black nodes. So now we can see, for example, I am considering here it is 10, 20, 30, 40. So here RB tree, first of all, it is a binary search tree, and satisfy these properties. Now we can see 10 is the root node. Okay, any new node you can take the red color, but root node must be a black color. 20 can add right of 10. Here it is a red color. 30 can add right of 20. It follows the binary search tree principle, right? Here it is a red. Now we can see red, no two adjacents. So 20 here 20 and 30 are adjacent nodes. So here no two adjacent nodes are red color, but here the red violation is there. So how to follow the two cases is there. Okay, what is that cases? If red violation is there, the parent sibling, if the parent sibling is black color or null, so here there is no sibling. What is meant by sibling? So here 30 parent is 20 sibling, that means share the same parent. Okay, so here there is no node, it is null or black. In that case we have to perform rotations and change the color. Okay, so here what type of notation we have to perform? Here it is 20 is the right of 10, here also right, RR is there. So already in AVL tree we have discussed what is meant by notations. Have the LL, RR, LR and RL. These are the four notations we have. Okay, if tree is not balanced. So LL means left of left. Whenever you can see the left of left, you can perform the single right rotation. Single right rotation. LR. That means here R is there. First you can perform in that left rotation and right rotation. Left rotation and right rotation. So here in this case we have two rotations. Two rotations. Here double rotations. Here it is single rotation. Single rotation whenever LL and RR is occur. RL is so L here. Now you can see the RR is there. So it is a single rotation. What is that rotation? Left rotation. So after performing rotation, you have to change the color. Now you can see. So just tag the thread here, pull down in the left direction. 20 become the, here it is parent of 10. Here left 20 left is here, right is 30. Now you can see that here 20 is the parent of 10 is the parent of 20, 20 is the child of 10, right? But in this case you can see whenever you can perform the left rotation, 20 become the parent of 10. Okay, 10 is the child. So these two are changed. So now it is a child of 20, 20 is the parent of 10. So that how to change these two colors only. Okay, 30 is the color is as it is. You can note down here. It is a red color. Now 20 is the red color, right? How to change it to black color. Here the 10 is the black color. How to change it to red color. Why? So 20 the designation is changed. So it is a child of 10, but now 20 is the parent. Here the 10 is the child of 20. So that have to change these two colors only. Okay. So this is the step. If next step is, for example, if you want to add 40, where you can add 40? Here you can see, you can add the 40 here. This is the, okay, any new node you can take the red color. So again here the red violation is there. Okay, again you can see before adding this 40, okay, three properties is there. Root node is a black color. Here you can see the root node is a black color, and two adjacent nodes are red color. There is no red violation. Okay, next is equal number of black nodes. Each and every path equal number of black nodes. Here you can see the, this is one path. Path means the root node to the leaf node. Okay, that is the one path. Sequence of the root node to the leaf node, it is a one path. So in this path having one black node, in this path also having one black node before adding 40. Now you can add the 40. So it is in a new node you can take the red color. Again you have to check the condition. So the 40 parent is 30. So 30 sibling is red color. Now you can see in this case there is no sibling and there is no, okay, for example here the node is not existed, that is null. Okay, if it is node is existed, if it is black color, in that case you have to perform rotations. But in this case you have to see red violation is there. The parent 40 parent is 30, 30 sibling is 10. Okay, sibling is 10. So that here both are red color, parent and sibling are red color. Then you have to change the red color to black color here, and also have to change the grandparent of 40, that is 20 can change. So okay, the 20 color is black, you can change it to red color. But if it is root node, leave it as it is. If it is not root node, you can change that color also. Okay, now you can see the insertion algorithm for the red black tree. So this is the procedure. Insert the new node with the color red, and case 1 node is root, recolor it black. Okay, so in red violation is there. If the new node parent is red color, in that case there are two cases is there. If the parent sibling is red color, parent sibling, okay, recolor the parent and sibling to black color and the grandparent to red color. then repeat the picks up process from the grandparent, okay, up to the grandparent. If the grandparent is a root node, leave it as it is, the black color. Otherwise it can change the color black to red. Okay, next second case is parent sibling is black color or null. In that case, perform rotations to balance the tree and recolor the node accordingly. Already we have discussed. Now we can see the one example, then you can understand what is how can insert node into the red black tree. So this is the example. Construct red black tree inserting the keys here. For example, first one I am consider here 41. Okay, any new node can take the red color, but it is a root that's why it can take the black color. Okay, so you can check the red black tree properties. Okay, there is no red violation, root is the black color, and each and every path having equal number of black nodes. Okay, then you can add the 38. Where you can add 38? Okay, you can add 38 on left of 41, right? Here you can add, it is a red color. Any new node you can take the red color. Again you have to check, after adding each and every node we have to check, is there any red violation? Okay, if the root is a black node, and you can check the is there any red violation, and then you can check each and every path having equal number of black nodes or not. Okay, in this case the root is the black. Okay, next there is no red violation, right? So each and every path having, so this is the one path having one black node, this is another path having one black node. Okay, it is satisfy the red black tree property. Then you have to add 31. Where you can add 31? So 31 will be added here. 31 is added here. Okay, you can add the 31 here. This is also red. So now we can see that red violation is there. So what is the insertion algorithm for the arbitrary? Whenever red violation is there, we have to check the sibling of the parent sibling. So here you can see, so there is no parent sibling, right? The parent sibling is black color or null, that means not existed. In that case we have to perform rotations. What type of rotation you have to perform? Here you can see, here it is a left of left, right? So 38 is added left of 41, 31 is added left of 38, so that it is a left of left. So we have to perform single right rotation. So single right rotation you have to perform. So how can perform single right rotation? Now you can see, just tag the thread here, just pull down in the right direction. Now 38 become the parent. Here you can see 38 become the parent. Okay, 41 is right of 31. Here it is a 41, right? It is a 41. Now left is 31. So what the two colors is changed here, you can see the 41 is the parent here, but in this case the 41 is a child of 38. 38 is the child is 41, but here you can change the 38 is the parent. So we have to change these two colors only. 41 the color is black initially, but it is changed to, okay, 41 is black, you can change it to red color. 38 is the red color, right? Have to change it to black color. Okay, 31 is red color. Okay, you can maintain the same color here, because here you cannot change the designation, right? It is the child of 38. 31 is the child of 38. Still it is also child of. Okay, so that you can check the red black tree properties is satisfied or not. Okay, the root node is the black color, right? So there is no red violation, right? So each and every path in these two paths is there here. This path having one black node, this path also having one black node. So that means equal number of black nodes is there each and every path. Then we have to add 12. Where you can add 12? You can add the 12 left of 31, right? We have to follow the BST. Okay, 12 is added here. So which is also a red color, right? Which is also a red color. So again the red violation is there. Red violation is there. Okay, whenever red violation is there, you can check the sibling. Okay, if sibling is not existed or black, you have to perform the rotation. But in this case you can see the red violation is there. Okay, the parent of 12 is 31, 31 sibling is 41, right? So the sibling is red color. If the sibling is red color, we have to change the color red to black. Okay, have to change the color red to black, both parent and sibling, and also grandparent also. Grandparent means 12 grandparent, and also up to the root node. But here the grandparent is the root node, so you cannot change the color, leave it as it is. Otherwise you can change the color. Okay, again we have to check the red black tree properties is satisfied or not after adding 12. So here you can see the root node is the black node. So in this path having one black, two blacks is there. Here also two blacks is there in this path also. So the red black tree the property is satisfied. Now you can add next node 19. Where you can add 19 when compared to this one? Here also can compare. You can also compare 12. Here the 19 is added right of the 12. Right, 19 is added here. Any new node you can take the red color. Okay, now again you can check red violation is there, red violation. Then you have to check the sibling, parent sibling. So 19 parent is 12, okay, 12 sibling. So here there is no right child of 31, right? So that means there is no sibling for 12. So there is no sibling. That's why here you have to perform the rotation, right? Simple two operations. Okay, either you can check the parent sibling is existed or not. If it is existed, if it is red color, we have to change the parent and sibling color. Otherwise have to perform the rotations. Now what type of rotation you have to perform here? It is the left. Okay, 12 is the left of 31. Okay, here the 19 is the right of 12. Here it is a right. So here LR is there. Whenever you can see the LR, we have to perform two rotations, double rotations. First you have to perform here, R is there, we have to perform left rotation, have to perform left rotation, and then right rotation. Here it is right rotation, have to perform first left rotation and then right rotation. After performing left and right rotation, after that, after two rotation you have to perform, then you have to change the color. Okay, now you can draw the diagram here, the tree here 38, and if you can first you can perform one left rotation. Okay, 31 will not change here. Okay, just tag the thread here, pull down in the left direction. 19 he is here, 19, and 12 he is here, 12. Okay, now here also 41 is there. Here it is a 41, right? It is a black color, it cannot change. Here it also black color. Now after that we have to perform the right rotation. Where you can perform right rotation is performed here, because it is a left, so we have to perform right. It is a right, we have to perform left. So that left is there, we have to perform right rotation. So now we can perform the right rotation. After performing right rotation, here you can see the tree here 38. Here the 19 become the parent of 31. 19 right is 31. Okay, here 31, here it is a 12. Okay, and here it is 41. It is a black color, it cannot change. Here also black color. Now we can see what is the color of 19. Here the color of 19 is red color, color of 12 is red color. Okay, color of 31 is the black color. Okay, you can see that. Now what are the two nodes are changed here? You can see 19 and 31 will be changed. Okay, 12 become the child of 19. Okay, we have to change these two colors only. So that here the 19 is red color, we have to change it to black color. It is black color now. 31 is the black color, so we have to change it to red color. 12 is color is red. Okay, leave it as it is. Again we have to check the red black tree properties. So 38, this is the root, so the root become the black color only, so here also black. And each and there is no red violation, and each and every path having two black nodes in this case. Okay, in this path having two black node, in this path also having two black nodes, in this path also having two black nodes, so that the red black tree is property is satisfied. Then how to add the next node? Okay, the node is 8. Where you can add 8? You can add 8 here. You can add 8 here. Any new node you can take the red color. Again you can see the red violation is there. When our red violation is there, parent of 8 is 12, 12 sibling is 31. You can see the parent and sibling color red. Then you have to change it to black color. It is a black, here also black. And also can change it to here the grandparent color also. Grandparent is black, you have to change it to red color. Okay, and also can change it to the grandparent, okay, up to the root node, but the grandparent is 38. Now leave it as it is, otherwise you can change that color also, black to red. Okay, now you can see that after changing this, it is satisfy the red black tree property or not. Here the root node is the black node, so in this path having how many number of black nodes is there? Two black nodes. Here also having two black nodes, here also having two black nodes. There are three paths is there, so each and every path having equal number of black nodes. Then you have to add the next element 5. Where you can add the 5? Here the 5 is the left of 8. Okay, here also it is a red color. Again you can see that red violation is there, but in this case the parent of 5 is 8 sibling. Here you can see there is no sibling, that means there is no right child for the 12. Okay, no sibling is existed. Then you have to perform rotations only. So what type of rotation you have to perform? First you have to identify the which type of notation. Okay, which is 8 is the left of 12, that's why it is a left. Okay, here it is also 5 is the left of 8, it is a left. So left is there. We have to perform the right rotation, single right rotation. That means you can tag the thread here, just pull down in the right direction. After performing right rotation, the tree becomes, here you can see 38, and here it is 19, here it is 19, right is 31, right? Here 38 right is 41. Okay, here you cannot change the color on right side, so that the color as it is. And 19 color is red color. Okay, 31 color is a black color here. Then if we can change that, here the 8 become the parent of 12. Here it is 8. Okay, so right of 8 is 12. Here it is a 12. So left of 8 is 5. So left of 8 is 5. Okay, you can take the same color here, red. So here the you can change the only 8 and 12 colors only. Okay, 8 is the red color, so we have to change it to black color here. 12 is the black color, we have to change it to red color. Okay, now you can check, is there any red violation? There is no red violation, so the root node is the black color. Okay, the root node is the black color. Here you can see in this path having two black nodes, in this path also having two black nodes, in this path also having two black nodes, in this path also having two black nodes. So each and every property is satisfied, so that this is the red black tree. Now you can add 1. Where you can add 1? Here you can add the 1 here. You can add the 1 here. Then again the new node takes the red color. Again you can see that red violation is there, so that okay, whenever you can see the red violation, the parent sibling is red color, so that we have to change it to black color here, have to change it to black color here. Okay, and also change it to grandparent color, black to red, and also change it to next grandparent. But before changing that next grandparent color, here we have to see, here it is a red violation is there. Now you can see this is the problem. Here you can see this is, here the red is there here now. So you can solve that problem. You can see that here the red is there, here red is there, so that sibling of okay, 8 parent is 19 sibling. You can see the 19 sibling means you can say the same parent. So 19 and 41 parent is 38, so 19 sibling is 41. So here you can see the 19 sibling is 41, that is black color. Okay, that is black color. Then you have to perform okay, rotations only. If existed, that is a black color, or if not existed, that is null. In that case, we have to perform rotations. Okay, so what type of rotation you have to perform? You can see 19 is the left of 38, so it is a left. Here also left. Left is there. We have to perform right rotation. Okay, after performing right rotation means just tag the thread here, just pull down in the right direction. 19 become the root now. Here you can see 19 become the root. Okay, then 19 left, 19 right is 38, 19 right is 38. Here it is a 38 is there. Okay, and 38 right is 41. You can note down as it is here. It is a 41. The node is 41. Okay, later you can give the colors here. First we have to perform the rotations. So here the 19 left is 8. So here the 19 left is 8. Okay, 19 left is 8, 8 left is 5, 8 left is 5, and 5 left is 1, right? 8 right is 12. Okay, and then here what the next node here is, it is 19 right is 31. So 19 is the root node here. The 31 is added on right side. Whenever you can add the right side, you have to compare with this 38. So 31 is the smaller element, so that we have to add here 31 is the left of 38. Okay, so now this is the tree. Now we can, what are the nodes we have to change here? These two are changed, right? These two are changed. Now 19 is the parent of 38, 38 is the child of 19, so that I have to change these two colors only. Okay, now 38 is the black color, 38 is the black color, I am taking here it is a red color now. 19 is the red color, I am taking here it is a black color. And 8 is the red color, 8 is the red color, 5 is the black color. Okay, 1 is the red color, 1 is red color, and 12 is the black color here, and 31 is the black color, and 41 is the black color. Now again you can see that, is there any red violation? You can see any red violation? There is no red violation. The root node is the black color, and each and every path you can see that in this path having two black nodes, in this path having two black nodes, in this path having two black nodes, in this path also having two black nodes, so that it is satisfied red black tree properties. Okay, then you have to add 2. Okay, where you can add 2? Now we can add 2 here. You can compare with this. 2 is added here. Okay, any new node you can take, the color is red color. Again it is a red violation. Okay, then you have to check the parent sibling. So here there is no right child of 5, so the sibling is null, so that you have to perform rotations. So what type of rotation you have to perform here? You can see that what type of rotation you have to perform. Here it is, here the right, here the right, here 1 is the left of 5, here the left, so LR is there. We have to perform 2 rotations. So first we have to perform left rotation first. Here you can see the R, have to perform left rotation. After that we have to perform right rotation. We have to perform right rotation, right? Here the right, here the right is there. We have to perform left rotation. It is left. Okay, now we can perform the rotations. Now we can see that here the diagram, here it is 19. Okay, first of all you can perform one rotation. After that here it is, you can see just tag the thread here, pull down in the left direction, and here it is a 5, and 5 left is 2, 2 left is 1. Okay, so 8 right is 12, 8 right is 12, and also left subtree is as it is, so it is 38, right? It is R, and it is 31. Okay, which is a black color. Here also 41, which is black color. Okay, now after performing this, we have to perform this right rotation, right rotation. Just to have to perform right rotation. Now our 19 color is black color here and 8 color is red color. Okay, then first you have to perform the rotation in this case. Okay, here you can see you can perform the right rotation. Just tag the thread here, pull down in the right direction. It became, here it is 19 and it is 8, it is 38. Okay, and then here it is 31, here it is 41. It is black color, it is red color, it is black color. 31 color is black color. Now the 2 become the parent of 5. Here it is 2 become the parent of 5. So 5 is the right of 2. So here it is 1. So which are the nodes are changed here? The designation. 2 become the parent of 5, 5 is the child of 2, so that have to change these two color only. Okay, initially 1 is the red color, right? Here it cannot change the color, one color is red color, and you can change two color is red. Here the two color is, now it is a black color, and 5 color is black, so here it is changed to red color, and 8 color is red. Here you can take the as it is. Now again, is there any red violation here? You can see after performing these two rotations. Okay, so the root node is the black node. Each and every path there is no red violation, right? So in this path having two black nodes, in this path also having two black nodes. Here the 12 is also there. Here you can see 12 is there, and the 12 color is a black color, right? Okay, now we can see in this path having two black nodes, in this path also 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 having two black nodes. That means each and every path having two black nodes, equal, it is equal, maybe two or more than that, but each and every path having equal number of black nodes. Okay, it is red black tree is satisfied, it is a red black tree. Okay, okay, where you can add the 4 here? 4 can add left of 5, you can add the 4 here, which is also a red color. Red violation is there. We have to see that parent sibling is 1. Okay, 5. Okay, 4 is the child, 4 parent is 5, 5 sibling is 1. So here it is a red color and the parent is also red color, so that's why it is a red violation is there. So that you can check the sibling color. Sibling is also red, have to change it to black. Here also can change it to black, and also change it to grandparent color black to red. Okay, and also can change it to grandparent, but here it is a red violation is there. First of all, you can solve this red violation, so this problem you can solve now. Okay, you can see that here also the red violation is there. First you can solve that red violation. Okay, now you can see that how can solve this red violation. Okay, here is the child. Okay, this is the parent sibling is red color, then we have to change it to black color. Here it is changed to black, here also change it to black, and also change it to the grandparent, but grandparent is a root node, so leave it as it is, otherwise it can change it to red color also, so that okay, it is a final tree. Okay, now we can see that. Okay, now we can see that here this is a tree, right? You can see that here it is. If you can count, what is the left subtree height? 8 left subtree height is 1 2 3. Okay, you can consider the maximum, right? Here it is a 3. Okay, what is the right subtree height? Only 1. So 3 minus 1 2. So 8 balance factor is 2. Okay, it is not allowed in AVL tree, but still it is a red black tree. So that is the difference between AVL tree and red black tree. So that's why AVL tree is much stricter than RB tree, but insertion and deletion is easy in red black tree. Okay, maybe it is not. You can see that it is not a balanced in case of AVL. Okay, it is 8 become the balance factor is 2, but still it is a red black tree. Okay, so that is the difference. Now after adding 4, you can check that Now you can see one black, two blacks is there here. Okay, three blacks. Here also can check one black, two black, three blacks. Here also one, two, three blacks. Here also one, two, three blacks. Here also one, two, three blacks. So each and every node having equal number of black nodes. Now we can add. Now we can add 7, right? We can add 3. Where you can add 3 here? 3 is added here. 3 is added left of 4. So here also red violation is there. So red the parent 3 parent is 4 sibling, so there is no sibling here. Okay, that's why you have to perform rotations only. So what type of rotation you have to perform? So 4 is the left of 5, here the left, here also left. LL is there, we have to perform, okay, right rotation. We have to perform right rotation. After performing right rotation, we can see that the diagram is, okay, 19 here it is, here it is 8. Okay, just redraw the same tree here. It is a black node. Carefully note down the colors here. So which is updated color is black. Okay, now 8 left is 2. Okay, here 2 left is 1. So one color is black color and two color is red color. Then you have to perform the right rotation, right? Now here it is parent is 4, here it is left of 4 is 3 and right is 5. Okay, now you can see that only can change these two colors only. Okay, 4 become the parent of 5, 5 become the child of 4, so that we have to change these two colors. 4 is red color, we have to change it to black now, and 5 is the black color, we have to change it to red. So 3 color is red, leave it as it is. Okay, now we have to see 8 right is 12, right? Here it is a 12 which is black color. Okay, this is the case. Again we have to check root node is the black color, right? Here we can add 31, that is black node, and 41 which is also black node. Then is the root is the black node, so is there any red violation? There is no red violation. You can check the equal number of black nodes are there in each and every path. You can see 1 2 3 black nodes, 1, okay, 2 3 black nodes, 1 2 3 black nodes, 1 2 3 1 2 3 1 2 3. So each and every path having equal number of black nodes. Now we can add 7. Where you can add 7? Here you can see when compare with this. Okay, 7 will be added here. Okay, 7 will be added, but when compared to 2, 7 here, when compared to 4, okay, 7 will be added right of 5, here the 7. Okay, again here you can see the red violation. So you can see the parent is 5, 5 sibling is 3. So here it is a red color, here also red color. How to change it to, now you can have to change it to black color. Okay, now it is changed to black color. Here also change it to black color, and also change to grandparent color is black to red color. Okay, now we can see that here the red violation is there. Now we can see, just I can change the color here. Now we can see that here it is red violation is there now. Okay, red violation. Again the red violation is there. The 4 parent is 2, 2 sibling is black color. Okay, so 2 sibling is black color. We have to rotate. Okay, we have to rotate. What type of rotation we have to apply here? 2 is the left of 8, so that, okay, which is the left and which is right. So because here this is the child, okay, parent 4 parent is 2, 2 sibling is 12. Okay, it is black color, so that you have to perform rotation. Which type? Left rotation and then right rotation. Okay, first you can perform left rotation and then right rotation. Okay, after performing this, you can see the diagram here. Okay, which is 19. Here it is 8. It is 38B. Here it is 31. Here it is 41. This is the black color. This is also black color. Now first you can perform, here it is a left rotation, that means it is a 4 and 4 left is 2 and 2 left is 1 and 4 right is 5. Okay, 5 right is 7 and here you can see the 4 left is 3 is there, 3 will be added on left side. We can compare with 2, 3 is added here. Okay, so you can see that okay 12 is there here, 12 is the right of 8. Okay, these are the nodes. You can see that any node is missing. Okay, now you can see that it is a black color, right? It is a black color. Okay, which is 8 color is here black color, 12 color is a black color, 4 color is a next here can only one single rotation is performed, right? After that we have to perform another rotation. Initial the 4 color is red color and the 5 color is black color. Okay, 7 color is red color and the 3 color is black color. Then 1 color is black color, 2 color is red color. Okay, after that we have to perform the right rotation. Okay, next how can change the color later you can see after performing next second rotation. Okay, now we can perform this rotation. Okay, now we can see the diagram here, it is 19 and you can perform here the 4 become the parent here, 4 become the parent and it is 38, right? Here it is a 41, here it is 31 which is black color, 38 black. Okay, now 4 become 4 right is 8, here it is 8, 8 right is 12, 8 right is 12, right? 4 left is 2, 4 left is 2 and 2 left is 1, 2 right is 3 and 4 right 5 is there. We have to compare with here, the 5 is added left of 8. Okay, 5 is added here. Okay, now you can see that here it is a 7. Okay, now you can see the colors. Now just you have to change these two colors only. 4 8 colors, 4 color is actually it is a red color. Now we can change it to black color and 8 color is black color. Sorry, here it is a red black color. Now have to change it to red color. 19 color is as it is, remaining color as it is, have to note down here. It is a black, here black, here black. Okay, 12 color is black color, here you can see. Okay, 7 is red color, 5 is black color and 3 is black color. Now okay, 1 is black color, 2 is red color. Now again you can check, is there any problem here? 1 black, 2 black, 2 blacks is 3 blacks is there in this path, also having 3 blacks, in this path also having 3 blacks, in this path also having 3 blacks, in this path also having 3 3 3. Okay, so each and every property is satisfied. So this is the red black tree, still it is a red black tree. If any node is missing you can check, just you can add that. Okay, now where you can add last element is a 9, where you can add 9, here you can check with. Okay, 9 is added left of 12. Okay, 9 is added here which is a red node. Now we can check, is there any problem? So the parent is a black color, child is a red color, so there is no red violation, still it is satisfied. You can see that, is there any problem? Now we can check once again. So you can see this is the one path, this is one path, right? You can check 3 black nodes is there, here also 3 black nodes is there. Okay, in this path also 3 black, in this path also 3 black, in this path also 3 black, here also 3 black nodes is there. So each and every path having equal number of black nodes. So this is the red black tree we have to practice with different keys. Okay, this is the final red black tree. Okay, thank you for watching this video. So next video where you can discuss about how you can delete elements from the red black tree. Thank you for watching. Please like, subscribe and click the bell icon for the latest notifications.